Today I'm going to talk a little bit about the history and the future of blockchains, but really I'm going to be talking about Generation 3 blockchains, which are application specific and interconnected. Just to go over briefly the plan for this week, today we're going to begin with this talk. Next will be Marco speaking a little bit more in depth about Tendermint and BFT consensus in general. Then we'll have two other sessions today, one from me and one from Alessio. Probably Alessio will actually go before mine here, it's switched, but it'll be kind of a crash course for Golang 101. And then I'll be going through a series of blockchain topics of interest. Tomorrow we're going to do hands-on workshop with the SDK, be with Marco. And then the second half of the day will be hands-on interacting with SDK apps from the client side, so JavaScript mostly. Wednesday will be more advanced topics inside the SDK with Alessio. And then if you guys are up for it, we thought maybe we'd do something like a mini hackathon where we can all build some POCs. We'll all be around to sort of help with that. And just sort of either you can go on your own topics or we will lead our own topic as well and you can just join our session as you wish. Format, we were kind of thinking, since these are such long chunks, that we do hour-and-a-half sessions, 15-minute breaks, basically 4 of them a day. So about me, my name is Billy. I'm from Louisville, Kentucky, which is the home of bourbon, racehorses, and bluegrass music. So if any of those topics are interesting to you, please chat with me later. I'm a developer relations engineer at Tendermint. I began working on the Looney Wallet, Block Explorer, which is a front-end application, so I have a history in front-end development. I started learning Golang within the company and taught it to myself by building the NFT module. It's not part of the modules repo. I come from background in Ethereum as well. I was working as a ETH dev for a year or so before joining the company, so I'm very familiar with Solidity, all of the pluses and minuses of working in that environment. Very excited about the sort of interactions between Solidity environments and Cosmos SDK, especially with regard to the Ethermint module. So if you are excited about using Solidity, or you have a lot of work in Solidity that you've already done, or you want to transfer it to something that might be application specific, if you're not, you can always use the EVM module for that. And this year I'm really excited about a concept called burner chains, which will be a series of proof of concept chains that have very short time frames in mind. It's about having minimal security. So don't kill yourself about having the most distributed, the most decentralized validator network. Just do a single validator, low security, but for the proof of concept of saying, what is this chain actually capable of doing? You know, what are the aspects of it that are interesting? You know, more about the application, because what becomes really possible with Cosmos SDK is that you start thinking about building applications instead of building blockchains, which I think is basically the way most developers would want to think about building products, and enables a lot more interesting attributes than just, this is the most decentralized secure thing that I've ever had, but it has no use and nobody uses it because it doesn't do anything beyond just keeping a set of things in order. I mean, obviously these are important aspects, but we want to sort of enable a wider variety and a more robust user system. Previous to the company, I was a sole proprietor in many aspects. I studied film and electronic art, actually. So I was working with net art, internet art, concept called surf clubs, and sort of the art world within New York and Berlin. A lot of the work was related to technology, and eventually I got more excited about the tech side than the art side. I've also been running a dev and design studio in Berlin called Bin Studio. I have a game on the Ethereum network mainnet called Clovers that launched last August. I've done a lot of work around bonding curves that we'll get into in the fourth presentation today. I've done work with Gnosis, Aragon, and art blocks on different concepts, and I'm an avid hackathoner. So I find hackathons a really useful way to sort of learn something, try things out. So that's sort of why I was a big proponent of that being a part of maybe our session this week. Take it as we go, though. So I'm sure you've sort of been inundated with the evolution of blockchain a few times, but I'm just going to go over it once more. You can remember one point, there was just Bitcoin, and if you wanted to do anything decentralized, your option was basically forking Bitcoin. It was a big, messy code base, it was hard to use and hard to modify, so basically you had the option of forking it and changing some of the easy parameters, like the reward mechanism, or what is the pre-mine, you know, so this was sort of the first great wave of shitcoins, as I like to call it. But as you know, in Bitcoin you have UTXO system, you have fee by TX size, you have a little bit of scripting language with Bitcoin script, and of course it uses proof of work, but mostly you had very little ability to change what was there. You also had Counterparty and colored coins, which really did open up kind of a variety. Counterparty was essentially using what is essentially the memo field in the Bitcoin transaction and just adding arbitrary data there. You can basically add your own sort of code or signifiers or secret words or whatever, and they get built into the blockchain, and then it becomes up to a secondary app to parse that logic and decide this is a valid state transition or not. So you're not actually storing the state of the app inside of Bitcoin. All you're doing is just changing the vectors of that app state. You know, what is something that changed that I should record somewhere else? And so that enabled a lot of kind of similar to ERC20s. There was a lot of new tokens that were built on top of that. There was also Rare Pepe was this sort of, it was the first like collectible kind of game built on Counterparty. And colored coins is just sort of a general concept that is the same thing. I tried building with these things back in the day. I think it was around 2014, and it was a pretty terrible experience. It's actually why you see Ethereum coming about, because it was such a bad experience. You couldn't really fit everything that you wanted to inside of this process, and so work on Ethereum continued to the point that we had Ethereum. And Ethereum is really amazing because it's this Turing-complete virtual machine. You can technically do anything. Of course, we're working with restrictions from the VM, from the block size, from all these different problems with gas and things like that. It uses Ether as the feed coin, uses an account model instead of UTXO, uses Patricia Retriever storage, and it has this virtual machine that you can run this arbitrary code through. So instead of having the entire blockchain be your app, you would put apps virtualized inside of this common blockchain. But it sounds like you guys have been doing some Ethereum work this week and last year, so I won't go too deep into that. But I like to think that the usability of this sort of birthed the second great wave of shitcoins with the ERC20s that we all know and love from 2017. And so, but really, it did open up kind of a Cambrian explosion of new ideas and new concepts. Ethereum is so versatile and so sort of accessible that you get to have this sort of amazingly secured, accessible proof of concept space, or just real working condition things. So no other context would I have been able to deploy my game Clovers to a network which I don't have to secure myself, doesn't have to rely on my own security model for it. I know that it's going to be secured in these really crazy ways and accessible from anybody, not censorable. That's really, really special, and it opened up this really massive set of products and concepts. And it's had a couple of years on all the other protocols, so they kind of figured out how to run their blockchain. When I put quotes on that, I mean because they obviously had restrictions on scaling and with problems with gas and things like that. But it was good enough. It was good enough to be able to try out all these really interesting concepts around DeFi and shared security or low security models or trustless models of apps and things like that. So I've been really excited to see Cosmos get to the point in the last year that instead of focusing on just the infrastructure of building the blockchain itself or building the concept of these blockchains, that we get to start working with these really interesting core concepts that have been present inside the Ethereum ecosystem for a while. But of course, the system runs into problems when you try to fit everything into the same model. This is the notorious Trilemma, blockchain trilemma: scalability, decentralization, and security. You can never have all three. And this is a problem from trying to do too much at the same time, I think. So you can think about Bitcoin as, in a way, doing one thing very simply. Like a calculator. It doesn't do a lot, but it does one thing and it does it well. That's all it's supposed to do, so it's able to do it efficiently with such a small amount of hardware, software. And if Bitcoin is a calculator, then Ethereum's kind of like a compatible time-sharing system. So this is one of the first compatible time-sharing systems. I think it was at MIT. But back in the day, you would basically all share one big computer. You would get in line. You would have to only do your processes one after each other. Maybe there was an efficient system so that you didn't have to all literally stand in line and wait to load your disks. But that's essentially what we're working with Ethereum. And it doesn't make a lot of sense when you start dealing with large scales. The internet, of course, is not a single computer. So why should we really expect the blockchain to be? I don't know if you're familiar with this image. It's the Karna botnet, which was really amazing. It was this sort of illegal botnet that this researcher made. He realized that the internet was like largely vulnerable in all these different ways. So started deploying this, essentially a virus that started spreading across every other computer, but all the virus really did was just track whether or not the computer was online and reproduce itself. After sort of spreading itself across the entire world, they were able to have enough of the computer's control that they could start pinging every single IP address that exists. So this is around 4 billion potential IP addresses and checking whether it's online or offline. And so started recording that data for a full day. And so this is a snapshot of every single device that's connected to the internet. And whether or not they're online or not is the sort of density heat map that you're seeing. So blue means there's not that many that are online, and red means there's a whole lot of online. You can see it sort of turning on and off with the day and night. Not relevant to blockchain, but an image I really love. So in this system, though, you can see that these are all obviously separate computers. This isn't one big computer. It would never work that way if we wanted to have a whole world that was using technology like this. And they're also not using the same technology in each computer. They might be running Windows, they might be running Mac, they might be running Linux. If it's a web server, it might have Apache, it might have Nginx. If it's an app itself, it might be built with Ruby on Rails, it might be built with PHP, it might be .NET. So each one has its own sort of qualities and specific use cases that are done for different reasons. Maybe one has a massive amount of RAM, maybe the other one just has, maybe one's used for machine learning. It's obvious that not every computer is going to be able to do the same thing for every purpose. And so really that's kind of our thinking about why you want to design a blockchain network with the same sort of mentality. In the same way that the internet's not a single computer, the interchain is not going to be a single chain. The centralized network, of course, is going to be consisting of hubs and spokes, like the one in the middle. And so that's kind of been the thinking for how, if we had a real fully running, fully used by the actual population of the world network that is secured in a decentralized manner, distributed ledger, then it should also follow this sort of hub and spoke model. I'll get more into that in just a second, but some other sort of aspects of this stack that we've sort of envisioned is around the concept of specialization. So obviously wise man Plato said, each man is capable of doing one thing well. If he attempts several, he will fail to achieve distinction in any. I don't know how true this is on all accounts, but in some ways it does make a lot of sense. We sort of figured that instead of trying to build a blockchain that does everything at the same time, it should be built to do exactly what it's built to do, not do anything else. And that way you're not wasting resources, you're not wasting electricity, you're not wasting time, and you also are able to do that one thing really well. Specialization, again, sort of, if you try to do too much, like the Swiss Army life, you might fail. If you do one thing really well, like clip toenails from a horse hoof, just do that one thing really well. The other aspect is self-sovereignty. So I have a picture of a fork here because a contentious fork is sort of a last case scenario when you have a disagreement inside a decentralized network. If you recall the history of the DAO inside of Ethereum, it was an early project in which a lot of people invested money in order to fund further endeavors, but there was a reentrancy bug which allowed the account to be drained of all money. And the result of this was that there was a huge disagreement within the network about what should happen afterwards. A big group decided that there was no problem actually. Code is law. The code said this was possible. This was possible. That means it should be allowed. You can't go back on that. The whole point of this distributed ledger is that it's basically written in stone. You cannot rewrite history. It's unfortunate that happened, but that's a feature and not a bug. The other camp was this was obviously not the way the code was intended to be used. So do what I mean, not what I say is actually what should occur. And so there was a disagreement, and since there was no sort of ability to say this is actually the purpose of the network split. And that's where we got Ethereum Classic and the Ethereum network that we have today. In a lot of ways, you would actually want to say that the Ethereum Classic is Ethereum and the network we have today is a fork of that. But because the network that we call Ethereum today had the sort of blessing from Vitalik, it has maintained sort of branding around the canonical Ethereum network. Although that one actually has, on block so-and-so, this account should have all this money put back into it, which is sort of like an arbitrary rule added to the consensus mechanism. And this is something that you want to avoid and is much more possible to avoid if you have align incentives for the purpose of a chain. If you're not all sharing the same network, all trying to do different things for different reasons at different times, it's going to be a lot easier to say, this is the purpose of this network. We know that this went wrong. We want to upgrade it in this way. So we should be able to come to consensus on that and make these changes together. Similarly, inside of the Bitcoin community, it's often criticized that they don't innovate fast enough or do enough changes to the network, that moves slow, there's no agreement, it's maybe held hostage by a few core devs, there's like a lot of disagreement on how the thing should work, and then you have this group of miners who are actually the group who has the final say. So even if the community does say they want to do this, are the miners really going to do that? And it's because this idea of what is the purpose of this network was not fully built into the design of Bitcoin. And some would say this is a feature, not a bug, but it is sort of a feature that you get out of having a unified idea of what a network's purpose is the sovereignty to change it in the ways that it's meant to be changed. So you wouldn't have non-contentious forks. And the way we've been thinking about doing this is by first making it easy to build application-specific blockchains, and that's with the Cosmos SDK, a developer kit for making it as simple as possible. Kind of going back to this original idea of a network like Bitcoin doing one thing, the calculator, except for instead of being in that early day where your only option was to fork the one that exists and just change some parameters, we wanted to take the really difficult parts, which are mostly networking and consensus, do that for you as simple as possible, and let you focus on building an application using a language which is highly legible and highly tested, like Golang. So the software development kit is modular, so you have all these different aspects of it that you can either include or exclude, or if you want to make a custom one, you should be able to play with the other ones really nicely. You should be able to publish it like an NPM library, sort of import things from a community. Uses the concept of least authority so that no module is able to modify something inside of another module that it's not supposed to be allowed to. It's extensible, like I mentioned, Golang. And proof of stake is the general concept around the consensus mechanism that we use called Tendermint. Tendermint's really a core concept of what makes this possible. It is kind of the golden standard of proof of stake protocols out there. Obviously, we're working with a very short time frame to be a golden standard, but since time moves 10 times faster inside the blockchain space than any other space, I think that it's a very, very long legacy. We're going to go a bit deeper into Tendermint in Marco's session after this, but it's a mature, state-of-the-art, Byzantine fault-tolerant consensus network protocol. BFT's concept has been around since the 70s, I think, but it's never been used for a set of entities that was as large as a decentralized network. But the core concept is, if you've ever worked with databases at scale or computers at scale, you have a bunch of them and you need them to stay in sync. It's relatively easy if you're in control of all of them and you know what's going on each of those computers. You have different ways of doing that, but it becomes much more difficult when you have strangers maybe running aspects of them, potentially malicious or just potentially inept strangers who are not running their system according to the rules or up to date or something like that. And so how can you have a system in sync when you can't trust everybody at all times? The BFT stands for this Byzantine fault tolerance, which is sort of this concept of a Byzantine general who is trying to attack a city. He's got soldiers all around it, and if they all attack at the same time, they should win. But if they don't all attack at the same time, they will lose. So how do you get the message around to everybody that we must attack at this certain time? If you have potentially traitors inside your group who are not going to send the message, or maybe they're going to send the wrong message, and it's a question of how many of them do you need out of the percentage to make sure it works right. The other real interesting aspect about having a proof of stake network is that you can have vertical scaling. I'll touch on that again at the end, so I'm going to skip it for now. A really good aspect is instant finality. So as you're probably familiar with Bitcoin and Ethereum, you have probabilistic finality, which means that it's probably final at any given moment, because as soon as a chain that has more work done on it, a longer chain shows up, that's considered the most legitimate chain. And so even if you're a couple confirmations down, some stranger chain might show up, and then you have to reorganize the last few blocks. And so you never actually have finality, but the probability of it getting reorganized just decreases and decreases to almost nothing. And so that brings up a couple interesting and strange aspects. Say you're moving a transaction to somebody, you have to wait your level of comfortableness before you're okay with saying, okay, it's really not going to reorg anymore. This person has my money, now they can give me the goods, or if it's on an exchange or something like that. The other really strange thing is just in terms of web development. If you welcome. If you are familiar with any sort of like user feedback for an action, user clicks an action, they expect the sort of results to be finalized. So it's a really terrible user experience if you say, okay, do this thing, and you say, great, I'm glad that you want to do this thing. Now I'm going to show you a loading screen for the next 15 minutes, just in case something bad happens. So having finality is really great to say that there's not going to be a chain optimization. This is done, this is final, it's not going to go back. Tendermint's also been formally proven, which is great, and I think we're the only consensus network inside the blockchain space that has. And it's sort of built into the SDK out of the box, so that's all taken care of for you. The other one is IBC. So application specific is great, except for the fact that you don't have this sort of composability thing, which makes Ethereum so great. That shot a little while ago of all of those products are only possible because they can all sort of communicate with each other, either synchronously by state or build off of each other. So if it's a stable token from MakerDAO, it's able to be used inside of a decentralized lending protocol. It's able to be used inside of a NFT for buying and selling something else. Whatever, this sort of Lego block aspect is what's really amazing of these open APIs. Because blockchains at their core are just open APIs that you know are going to exist today, tomorrow, and the day after. Instead of something like Twitter, which might change the policy and you can no longer access tweets that are within this region that use that word or something like that. The idea of having public utility API is the sort of core use case, I think, of a blockchain. And the benefit of APIs, as we've seen for years, is the idea of being able to build upon each other, have sort of daisy chain services, and it really opens up a lot of possibilities. So if you're application specific inside of a SDK app, say a Cosmos app, you are all alone, like the way, say, Bitcoin is all alone or Tezos is all alone. So the final missing piece to sort of enable those open API aspects is called IBC. And it's the Internet Blockchain Communication Protocol. And it's really based off of TCP/IP, which is the communication protocol for the internet that we use today, which is agnostic of the content that's moving back and forth between computers, but it uses the same trusted system of handshake transport. And I'll go into that in depth here in a second, but it enables your blockchain to basically create a root of trust between two different blockchains, and then they're able to transfer information back and forth. It's arbitrary information, so it could be just I'm moving coins from blockchain A to blockchain B. It could be I have something to say, I'm maybe making a vote on blockchain B. Maybe it's even arbitrary call data, so you could have two EVMs on two different blockchains, and you're triggering different function calls and different contract addresses on different chains for different reasons. Because the polycentric interchain is actually already here. As William Gibson might say, though, it's just not evenly distributed. And what I mean by that is that you have a lot of blockchains already. It's sort of the third great wave of shitcoins that we're seeing, which is a bunch of independent networks that now are able to be built and have their own aspects. But they are having trouble communicating because there isn't this sort of trustless protocol communicating between each other. Some of them have trusted entities that go between. Some of them have clever schemes, but at the end of the day, none of them have like a fully trustless standard that isn't required on any sort of part of your system. So we have IBC, which is, again, at its core, messaging protocol. It consists of that protocol plus TAO, transport, authentication, and ordering, similar to IBC, to TCP/IP. And the protocol stack basically looks like clients, connections, channels, packets, and modules. So the first one is clients, which are like clients. These are taking headers from some other blockchain, and they're saying, are these headers valid if you run them through this light client? I don't need to check all of the state updates. I just want to know if the headers line up and make sense at the very end of it. The next one is the connections. once you've made this sort of connection by verifying headers between two blockchains, you can say, okay, I know that there exists some blockchain out there that has headers that end up with this sort of stack. So now we have a connection between blockchains. We know that each other exists. Then you have channels, which are, okay, now that we know each other exists, what are the types of things we want to say to each other? A really common channel might be transfer tokens. Another really common channel, like I mentioned earlier, might be I want to make a vote on this thing. I'll go into a couple other common ones in a second, but essentially a channel is like specific to a type of communication. Packets is where all the action is at. It's basically the content that's getting moved over. And IBC TAO is agnostic to what's inside of those packets. It's just serialized bytes. So it can be your mother's maiden name, it can be your dog's name, it can be a transfer packet, it could be your last will and testament. It doesn't really matter. And just to walk quickly through what sort of a visualization of that looks like is, oh God, I'm really speeding through this. Maybe can I stop right here and just ask, are there questions so far about the content up to this point? Because we have an hour and a half for this session, and I was going to try to slow myself down to 2 minutes per slide, but I've obviously done a lot faster than that. And I talk fast in general. Let's just take a pause here, and is there anything that you guys want to bring up again that we've gone over? Go over in more depth, topic that you want to ask another deeper question about?
I'm really interested about this IBC stack. So it's really similar to the TCP IP. So there is an interface. So you have to go through all the stack levels. It's just the same. It's quite the same. So there is interface between each stack.
Yep.
Sorry, between each level. How the data is passing from one.
Yeah. So
from one element.
It's like a sort of a hi, I'm here. Hi, I see you said I'm here. I'm here. Hi, you said I'm here. That you said I'm here, and then that back and forth. And then that's where the sort of root of trust is established with essentially the headers of those two things. And it's agnostic in the sense that like this person doesn't know this chain is Tezos or whatever. It just knows that a chain with that header exists, and then it becomes up to the people to say, yes, this is that network that I know. This is the current header. This is the one I want to talk to. This is how I know it's there. But the protocol itself is completely agnostic. So you could have a million sort of small chains, large chains, whatever, that can talk depending on that computer being set up, that network being set up to create new connections with any network. At the application level, you can also be restrictive about which networks you decide to allow transactions between, which ones you don't. Maybe you have like whitelisted headers, or maybe ones apply, and then the network decides to vote on allowing actual transactions to take place between them. But the actual process of handshake is something that can be done, trustlessly to establish the two things. And it's very much a back and forth like TCP/IP. So I mean, we can walk through a little bit what that looks like.
The other thing on IBC is like it's IBC is in a blockchain communication, but it's also from machine to machine. So it's like your SDK or platform only has to be a modular framework, and so you could actually do and what they're actually working on right now is providing a test where you have a non-blockchain machine that communicates with a blockchain, and then that will open up a whole new world to the blockchain ecosystem of getting off-chain data onto on-chain and then going down that.
So you can query also the chain from a device which is not part of the chain, or
so that example wouldn't be necessarily IBC. That'd be possibly like a light client, and I'll cover a bit on light clients. But in this sense, kind of like Oracle. So like an Oracle isn't on-chain, and the data is kind of, let's say, BigQuery from Google. You can send that data on-chain without having to, like writing a smart contract to get it on-chain and then sending it to a different chain. So it kind of blurs the line between blockchain and non-blockchain, which in the end is kind of like what is needed.
So is it creating oracles to implement that functionality? Is that?
It's kind of one use case of it.
Okay.
This is just kind of like a simple aspect of it. IBC is kind of a super, I mean, you'll probably touch on it next, but it's just like a super generalized messaging protocol. It has nothing to do with specific blockchains or anything.
Okay.
And like, I think a use case that I feel like I'm not supposed to be excited about, but I am, is essentially like single validator networks, applications that are, the same security level as just some normal internet application, but has the ability to use money as a primitive. I mean, we're used to representing money with numbers or maybe floats inside of programming languages, but very seldom do we actually work with money as an actual programming primitive, you know, the same way we would with Booleans or something else, that it doesn't represent money, it is money. And that if you have an application that can actually represent money, it really changes the way that you program and the way that, you know, you work with money online. So you no longer need merchant services who are basically the person who's going to redeem that thing that you said represented money into real money. Like, money is part of the programming language from the very beginning. And if you've ever worked with Ruby on Rails or something like that, just the feeling of being able to make any kind of application with a framework like that is sort of what we're going for with the SDK, where it's no longer thinking about trying to squeeze an application into a smart contract. It's about making an application as fully fledged as it wants to be and should be, with the features of money as a primitive. So just to walk through a little bit of what IBC is like. I mean, this is an example of IBC packet traveling between two blockchains after they've actually made their handshake and they know about each other. But you'd have module A, and let's say module A is just, you know, the bank module. So a bank module would take care of token balances. Bank module would, you know, be able to represent money basically. So any kind of denomination. It's kind of like an ERC20 module. So we're going to transfer money from person A to person B. So then it goes into the IBC module. And so these are two separate modules, but they have a connection between them using Keeper, and it's kind of like where the storage is kept. So the actual IBC module will take that request to send money, and it will wrap it in a packet that includes the proof of the blockchain A and the content that's going to be basically serialized as bytes and included in the packet. It will basically send it and put it in kind of like a outgoing messages queue. It's like, if you think about the whole thing like a postage system, it's like you put it in your mailbox outside and you say this needs to go out. And then you have what's essentially called a relayer. And a relayer is kind of like the postman, but it can actually be anybody. So the postman would maybe come up to your mailbox and be like, is there any outgoing messages? Sure, I could do it. Postman could also just be your wallet, it could be your phone, it could be a random service, it could be, it's a little bit like meta transactions actually, if you dealt with that inside of Solidity at all, where you sign the transaction but you don't submit it yourself, it gets included as a parameter into somebody else's transaction. So they actually transport it for you, they do all this sort of movement, but inside of that there's the intention from the real user doing the actual thing. So that's what the relayer's kind of job is. And they would take it from network A and move it over to network B. So they might just be sort of keeping an eye on this outgoing messages area. Once it lands in network B, it would, to basically the reverse, go into the IBC module. This is where it has sort of the existence of that other blockchain living, saying, okay, I recently got a transaction from this other blockchain. It has this header, which is in line with that one that said that I made a handshake with a long time ago. This packet comes in. Yeah, this is also part of that same sort of genealogy of headers. I'm going to update my sort of status of that other network, saying this is now the current header. I know this because it came into this packet. I was able to run a light client proof to prove that this is all valid. And now I look at the actual packet and say what's in there. This is happening here. I look inside that packet, see what's actually in there, and I see that it's addressed to go to this module B, where it's going to be able to be, sort of be parsed as a transfer event, like an ERC20 transfer. And this is where the really, really exciting part happens. This is the application layer packet semantics. So the one I just mentioned is sort of the token transfer that you can receive tokens. Another one is cross-chain account abstraction, which I think is really exciting. And that's where you, say you have the Cosmos network, for example. So the Cosmos network is meant to do a lot of things, but primarily it's meant to be routing. So if you've got cool app chain 1, cool app chain 2, and then you have cool app chain 3 through whatever, 1,000, it doesn't make a lot of sense for each of these numbers to be connected to each of those other ones. You know, it becomes connection squared. So instead, they should all use this sort of hub and spoke model, and the Cosmos hub is meant to be this hub. So you would instead just send chain A to the hub, and then that hub would send it to its destination chain. instead of needing to have a connection with every single other chain, you just have a connection between yourself and the Cosmos hub. Maybe you also want to have a connection to some other hub, maybe a specific couple chains, so that's up to your specific use case and things like that. But it'll cut down on the overhead and sort of complexity if you're able to all use the same sort of routes for moving things in between. So on each of these networks, you also have this concept of validators. The validator is sort of the replacement for a miner in a proof of work system. These validators are all running Tendermint, and they all have a system for being eligible of being the block producer. So in proof of work, of course, we know that you're basically playing this computational.
The Cosmos network, is it connecting different blockchains? What is the goal of the Cosmos network?
Yeah, so I have to apologize in advance. Our branding's a little all over the place because we use the word Cosmos for so many different things, but there's the Cosmos Hub, which is an actual blockchain that's been running since March of last year. And the goal of that hub is a couple parts. One is to be sort of a not proof of concept, but a sort of the most secured proof of stake network in existence as a sort of demonstration of how to run a network, also to have just high quality validators that can be validators on other networks. And the other one is to route packets for IBC. So IBC is in the process of being, I think the audit just finished on the spec, and the implementation is almost done. We're entering in
this audit for both the spec and the implementation is just about done.
So the demos have been around for a few months now, but the actual protocol itself is not live on the network. So in a way, the Cosmos Hub is not doing its final eventual goal, which is to be routing these packets for all these other networks. But that's the point of the network in general. And until then, I mean, and also just in general from all the other networks, you have this set of validators. And the validators are going through this sort of round robin system that is Tendermint, saying, am I going to be the block producer? Am I going to be the block producer? Am I going to be the block producer? And that process is determined inside of Bitcoin and Ethereum by this crazy random game called proof of work, where you're just trying to guess the hash, and if you get the hash, you get to produce the block. Instead, it's very orderly. What is kind of interesting is that with something like cross-chain account abstraction, you could actually have an entire network be a validator for a different network, or own money on behalf of another network. And maybe you want that network itself to vote on something on another network. So say I had a investment company and we all have this money in here, we decided to make our company into a network. So instead of any individual account owning some value of, say, atoms, our network itself could have a balance of atoms. And then our network itself is delegating our atoms to different validators, or being a validator itself, so that in a way it becomes like kind of like a DAO, where it's not a single entity that has these things, but it becomes a network that has control of these assets and can do different things. So this sort of opens up some bizarre capabilities within the whole network, that a network itself is like equivalent to a person. I mean, this was also one of my sort of favorite aspects of Ethereum, is the idea that there's no distinction between a contract and a human in terms of like owning Ether and being able to do actions and things like that. And this sort of opens up a similar thing, where instead of being a contract that can sort of act as a surrogate, you can actually have an entire network act as a surrogate for a person and a group of people and things like that. Another possibility on the application layer is code relocation. So you could transport contracts and packets. You can execute contracts and packets. It's sort of like whatever kind of data you want to put in there.
So let's say, I mean, for the Cosmos network, right? Does it like include the Bitcoin node and an Ethereum node? And is it part of the Cosmos network, and that's how you integrate with the different blockchains, or?
So there is a distinction between chains that are connected directly with IBC and chains that are connected via peg zones. So if you have fast finality, meaning you're not going to have any chain reorganizations, and if you have easy light client proofs, if you have fast light clients, then you are basically eligible to have IBC. If you have IBC included in your network, then you can automatically just sort of send IBC packets. So something like Tezos would be eligible because they have fast finality and they have simple light client proofs. Polkadot would be eligible. And obviously anything that builds with the Cosmos decay is immediately eligible. Networks like Ethereum and Bitcoin, since they're so probabilistic, you would never be able to trust an IBC packet coming over because maybe there's a chain reorganization and this IBC packet represents a header which is sort of valid to this point, but all of a sudden you could have another one that is technically valid because they use the longest chain rule. So what you do instead is you have concepts called peg zones. And a peg zone basically acts as a middleman with fast finality, and they watch the probabilistic network and say, okay, we are willing to sort of like reproduce the results of this network after 6 confirmations. Maybe another one's like, we only do it after 8 confirmations. So depending on the use case, you would have different peg zones for different security thresholds, for different speeds, and sort of benefit and drawbacks of each of those aspects, acting as the sort of middleman for those networks. Obviously, you also have a question of who is securing that middleman network. Could they just run off with the money? What is their incentive to do it? So you would have different reasons to use different peg zones depending on your use case as well. Probably we'll see a lot of exchanges be peg zones in these different ways. Aragon Network has begun building on the SDK, and they also want to sort of represent the peg zone for Ethereum. They want to sort of be one of the gateways from the Ethereum mainnet into the Cosmos network, interchain network.
So for Bitcoin, for example, there's the need of a middleman, right? To like because of the finality, right? And am I right to assume that like probably there's space for multiple middlemen,
Absolutely.
right? So that it's.
And you can imagine that different middlemen have different sort of threshold securities and different value to their services they provide. And so the kind of like wrapped Bitcoin that would be on the Cosmos network would all be attached to the different route that they took. So you'd have like a company A wrap Bitcoin, or company B wrap Bitcoin, and company C. Probably they'd all have different values based on what is the integrity of that network throughput or something like that. And this is a big distinction from what a lot of the thinking around Polkadot is that we sort of encourage the idea of very many different security thresholds and very many different paths between 2 different areas instead of having, we guarantee this is X, Y, or Z, because having sort of like a very large variety of aspects, features is sort of a positive for us, where sure, it might introduce a couple of sketchy scenarios, but it's much closer to a real live sort of working ecosystem where it's able to sort of fill the niches that it's needed. If people end up having more of a desire for low security assets, then that should be an option. You don't want to sort of over-secure anything that isn't necessary at that point. So it allows for a much wider variety of assets to come in, and then sort of the market itself can kind of decide what it decides is the things that will exist or thrive in that system.
When you say eligible, does it from a governance point of view? From
Eligible?
Yeah, so you said like to be eligible to communicate over IBC, you have to have finality. So that's from a governance will accept. No.
Well, it depends. So eligible in terms of the protocol IBC, there's no requirements. But in terms of the implementations of them, you have choices and distinctions you can make. So somebody like the Cosmos Hub, whose purpose is to route as many packets as possible, will most likely implement IBC with no sort of restrictions on who can establish these new connections between blockchains, because we just want to be routing them. It doesn't really matter to us that you locked up this thing, or you said you locked up that thing. It's up to the users of your networks to decide whether they care about it, whether they trust it, things like that. Whereas you might have another network, like say Kava, who they have a very specific incentive model on their validator system. They take a percentage of fees whenever somebody transfers money between 2 people, kind of like a merchant system. And if you were able to move their Kava stable token off of their network, they would no longer be able to guarantee that you were paying their validators every time you transferred it. And so they get to decide, okay, we will allow IBC packets to other networks, but only networks which we have an agreement with who will pay back our validators on their transfers. So we will allow these ones, so we can use IBC in this way, but they have their application level restrictions. Whereas IBC itself has no actual restrictions because it's just a protocol.
Just to see if I'm on the right track. So this scenario, for example, if I have my own blockchain, for example, and I don't want to implement the money handling, I can use this scenario through the Cosmos Hub and facilitate payments through Ethereum. For example, on my is it right?
Can you walk me
Is
through
it one of application scenarios for?
Can you tell me a little bit more about it again?
Like for example, I have my own blockchain, which you can you can do transactions and payments.
Okay.
But you don't want to do it on your own blockchain because you don't want to program it. So maybe you take care. You only be concerned with the data flow and things like that, and then you need some kind of payment. You can use through the Cosmos the Ethereum payment
I think I
platform, for
understand. So
example.
you said that you would have your own blockchain that has payments, but you also don't want to have payments on your blockchain?
No, but you don't want to have the mechanisms of keeping wallets and keeping.
So I guess using Ethereum as a payment mechanism,
Yes,
and then having your logic in a
and
separate
then
blockchain.
Maybe you want to use a token, which is
or
very
maybe you have
popular
your
on
own token, for
Ethereum.
example,
I see.
and then instead of having your own coin, you
Totally,
have.
totally, yeah. So in that scenario, it sounds like you mean like a token that's valuable already on Ethereum or something like that. You'd be able to move it, say DAI, like move DAI onto SDK chain, maybe directly onto your chain. Your users can interact with your system using a token that has real value, and then they can move it out and maybe exchange it on an exchange, sell it on an exchange via Ethereum at the very end of the day. Again, exactly, it would be.
It would be a scenario.
Yeah,
Okay.
very much so.
So in his example, right, from this other blockchain, right, and that would be like you using DAI, but DAI would always exist only on Ethereum, right?
DAI would get basically locked up on Ethereum.
Exactly. So you would be like there must be an interface from my blockchain to the Cosmos Hub, which drives these transactions which are happening on the Ethereum network.
There's a couple ways you could do it. So you would have, because DAI is on Ethereum and it's probabilistic, you would need a peg zone to begin with. So first you would have to either decide on a single peg zone or a series of peg zones, or let your users sort of decide and do it in a completely trustless way. So that you would have arbitrary peg zone, assets get locked up on Ethereum, they get minted on this peg zone, they get transferred either directly to your network or to your network via the Cosmos Hub. And then maybe you have 5 or 6 different types of DAI on your network. Maybe you restrict it so that you only have one version of DAI that only goes through this one path exactly. And then once it's on your network, it could do all the things it wanted to do. And then if somebody wanted to sell it and they weren't willing, nobody's willing to buy it on your network, let's say, maybe actually a better scenario or best case scenario is that they actually would be willing to pay USD for your wrapped DAI. But if nobody's willing to do that, you could always just move it back towards Ethereum and then sell it as native DAI because it would get unlocked once it goes through the peg zone again.
So in general, the integration, is it done through side chains?
I mean, I think Joseph Lubin sort of tried to downplay Cosmos as just sidechains.
I mean, I haven't read anything, so
I agree with that, but I think that's also the beauty of it is that it's just sidechains. Like, you don't need to reinvent the entire distributed ledger world. You don't need to reinvent consensus really even because we're using just BFT. You know, you don't necessarily need all of the bells and whistles that are kind of being sold as being part of Polkadot when you have just sidechains. You know, it's actually just that simple if you just have a bunch of roots of trust, daisy chains of trust between these side chains that you can sort of move throughout this sort of large ecosystem of connected blockchains, side chains. I mean, sidechain also sort of brings the idea that there's a main chain, so it becomes a misnomer, but you're right, in a way it is just sidechains. The other sort of thing I was going to mention was the vertical versus horizontal scaling. So I think a lot of people have been talking about how do we scale in a vertical way? How do we add more throughput to a single blockchain? Do we add more resources? Do we change the way that we handle those things? Do we use zero knowledge proofs, all these different things? But with something like this, you can actually have horizontal scaling. So if you have a single network that's doing a single thing, and you run into some sort of transaction limit through Tendermint, whatever that is, that's already much larger, then you can just have a second chain that communicates with the first one via IBC. if you continue doing this, you actually basically reproduce the entire sharding architecture, which is under development for ETH 2.0 and many aspects of Polkadot. These shards in these systems are essentially just independent blockchains, which are able to talk to each other via a protocol. And we've sort of built a protocol called IBC, and it's actually one of our goals is to try to see if it's possible to improve or maybe lessen the load of ETH 2.0 by using IBC for inter-shard communication on the ETH 2.0 roadmap. So again, this was the sort of like layout of what potential interchain looks like. Of course, this isn't a complete picture because to be a real sort of robust network, you need to have a lot more than one hub. So early on, we made a partnership with Iris Hub, which is a hub based in China that wants to be sort of a second alternative route for different reasons, for different purposes, blockchains, and we hope that there's many more out there as well. Of course, you need actual applications to be there doing these things, and that's really why we're out here talking to groups like you, is because we are building the tools to build applications, but obviously we can't build them ourselves, all of them at the same time. And so we want to make it so that instead of blockchain being just a highly speculative sort of gambling aspect of, yeah, I bet somebody's going to buy this from me at a higher price than I bought it from them, we want these networks to be valuable because people actually use them. And actually this goes into the core economic model of how proof of stake works, and especially the parameters around Cosmos Hub, which is that money is not meant to be made from what you call block rewards, like mining. So you shouldn't be expecting to have your validator business forever profit off of these new tokens that are minted every round, sort of like the block reward. We call them commissions, or what do we call them? Fees. Block rewards.
Or
fees. In Tendermint.
I mean, there's block rewards and fees.
But yeah, it's block rewards. Somehow I thought we were using a different name than what they use them for. Regardless, sorry. What it comes down to in the proof of stake model, I mean, so there's a very high inflation rate on these networks, especially, or more specifically the Cosmos Hub. Every time a block is produced, actually a very large amount of new tokens are produced. And sort of Bitcoin maximalists would sort of cry alarm at this because the whole point of Bitcoin, at least, is to have a deflationary token. There should only ever be 21 million at the end of the day, and that's why it's valuable, because it's scarcity. And that's very, very counter to the sort of way that Cosmos is thinking about proof of stake, because I think it's anywhere between 6 and 21% inflation.
7
and
21.
And the Cosmos side.
Mm-hmm.
So anywhere between 7 and 21% of inflation, which is very, very large. And the reason for that is that we don't actually want people to be thinking about getting this inflation and selling it. We want you to be punished for not being part of that validator network. So even if you're not running a validator yourself, if you hold tokens, you can delegate them to a validator and earn profits. So this is, earn profits, again, what I'm saying that you're not supposed to do. You basically are part of this sort of inflation system. And what's really great about that is that if you're not doing that, you're losing money through this inflation. So you're encouraged to delegate it to these validators. And the more token that's on delegations or being validated, the more secure the network is. Because say there were a lot of tokens which are not being delegated or not being used for validation, somebody who wanted to attack the network could buy up all of these tokens, get the required 1/3 of the network, use them to then split the network, stop the network, or censor the network in different ways. So this is like kind of the worst case scenario. This is like the attack system that we're all trying to prevent. And so we want to encourage people to not have even enough tokens on the market to be possible to be bought at any given moment to make sure that nobody can attack it in this way. And so we encourage you to have them delegated to being used in a validator system by cranking the inflation mechanism up. So if it's not to be sold on the network, if that's not the reason that you would be a validator, the only reason you would really want to be a validator is because if you make money from fees. And fees will only come if people are actually using these networks, if people actually have applications that people are actually using. So this is the sort of goal of this economic model, and to be a validator in these systems is that you need people to really use these networks. We can't rely on just like infinite bag holding, prospecting on the next person sort of pyramid schemes in these networks. We have to have applications that people use. And so we want to make building these applications as simple as possible, and want to let as many people know that it's simple to do so that they can build these applications and we can actually all use and have this decentralized network that functions in a way that is healthy because people are using it and not unhealthy because people are not. This is a sort of mandatory final slide. Cosmos Network link and a link to our hiring page. But also I should point out that as part of the release of IBC, we're going to go through a system called Game of Zones. So leading up to the launch of the Cosmos Network was a project called Game of Stakes, which was sort of an adversarial test network. So before the network went live, you would be able to run a validator on the test network, and you would have different sort of challenges to each other. And a very simple one is basically just to disrupt your neighbors, see if you can attack somebody in a way that nobody anticipated, see if you can spam them, DDoS them, overload their sentries. What are the different like infrastructure setup things that nobody thought of before, and create a system of rewards for anybody who can reveal these networks in a safe space, in a test network space. Because if this is happening on a live network, obviously you get into a lot of trouble with liveness. But following the success of that, we decided to do it again for the lead up to IBC. So in Game of Zones, instead of running a validator and trying to be part of the Cosmos network, you would run your own zone and then have it communicate via IBC, try to do nefarious things, good things, just test things out, and similarly bring in rewards so that people are encouraged to try these things out in a safe space like a test network instead of on the main network when it's live. So there will be 100,000 atoms given away for building and running Cosmos zones during this system. If you guys are familiar with running a validator at all, you might know that if you participated in Game of Stakes leading up to the Cosmos Hub, it was not only a great way to train yourself on being a validator, but it was also a great way to get advertising for delegations. So delegations, again, is when sort of normal token holders trust your validator to block produce, and it becomes, in a way, a popularity contest. And you really do win a lot of popularity if you're able to sort of show up during this very public game system about, hey, this is our validator, this is what we're doing, this is why we're doing it well, we found this problem, we published this patch, we did this really great thing with the community. All these sorts of things made the community what it is, and it's a very strong validator community. And so this is going to be another opportunity for sort of getting involved in that space in general with very low stakes to begin with, because again, it's a test network. I made it to an hour, which is just 30 minutes shy of what I wanted. I would love to go back and stop on any of these slides or topics, and we could go over again if anybody's interested.
Will you be covering the IBC a bit more in detail?
We will be doing a bit with the modules tomorrow,
Cool.
But
If there's a great amount of interest, we can also like play around with setting up. Everyone sets up their own like blockchain and IBC, and we can all communicate with each other.
yeah, totally.
That'd be nice, I guess.
No, what I would like to learn more about is this thing. Like, I know quite a lot about the consensus in Ethereum and Bitcoin, which have this finality problem. What makes Tendermint, what gives it this finality characteristic where, it's like 100% sure it's final? What's special about it?
I would maybe suggest we wait until the next presentation, which
Okay,
is all
so
about that.
It's gonna
We can do a full hour session on that. Is there anything else?
Another interesting thing about the SDK is like also this will kind of be expanded on in Tendermint, but since the application doesn't actually have consensus and networking in it, you could essentially take let's say the Libra blockchain, and then take out their virtual machine and then put the Cosmos SDK on top of Libra. You can take it out and take Substrate, take the runtime out of Substrate and put the Cosmos SDK on top of that. All you have to do is change about a couple files in the SDK, and then you can adhere and write your application on top of any blockchain. And so this changes a lot of the security characteristics that you may want for your application.
Yeah, I think that really points to what our sort of mentality around all this is, which is make the system extensible, no token lock-in, no lock-in to any sort of requirements, and then let people sort of build the networks and connect in the ways that they actually want to and will use. We try to be like have as few assumptions as possible about exactly how the network should run, but create as many tools that make as many different variations as possible. So like Marco was saying, sort of the swappability-ness of different aspects, or even just the idea that you could use Tendermint with different programming languages, that you could use a completely different SDK for building a blockchain, like Substrate he mentioned, and still use IBC to communicate between different ones. So similar to what I was saying in this slide is we want there to be, and we think there needs to be, a really diverse sort of ecosystem in terms of stacks, systems, applications, usage, and everything that we do is sort of meant to encourage that.
The Cosmos Hub, it's a blockchain itself, right?
Yes.
Which is running Tendermint.
Yes.
Okay. But you can also use Tendermint to build your own blockchain.
Yes.
Which is immediately like it plugs in beautifully in the Cosmos Hub.
Exactly.
Marco we will cover this. We'll cover Tendermint quite extensively,
Yeah.
at least
For me, it's the more interesting part.
Point of view. But Tendermint fundamentally handles peer-to-peer communication, handles transaction relaying, and handles the protocol, the consensus protocol itself. But Marco will cover APCI. APCI is application blockchain interface, which makes Tendermint fundamentally agnostic. So application agnostic. You can put it up on Tendermint anything you want. You don't even necessarily have to use Cosmos SDK to build your application. ABCI used to be called in the past TMSP, so Tendermint Socket Protocol, and it is a socket protocol, and it's meant to give you just the basics, the foundations to run your blockchain application. And then actually Tendermint has been extended by other parties. I met other parties that use Tendermint as a mere database. And they extended with a couple of modules, proprietary modules, and it's quite modular, and it's very flexible as well. And Marco will cover all the functionalities and the responsibilities of Tendermint or the Tendermint engine.
There's also a lot, like you mentioned, other sort of SDKs that use Tendermint. Yeah. So there's
IOV. IOV is kind of similar to the SDK. Yeah. Just they handle stores a bit differently, and so it's a bit less complex, but it can't handle as complex applications. There's you may have heard of Crypto.com. So their chain, the CRO token, is built on Tendermint with a REST application. eCoin is built in Erlang on top of Go Tendermint. There's the phone people. They do geographic radio coordination, and they have a Haskell application built on Go Tendermint, and so there's a plethora of applications on top of Tendermint. There's a couple of VMs. There's Libra VM, Ethermint, Cosmosm. So there's quite a few things built on it.
There's also Lotion.js, which is an interchain project that's just JavaScript as a developer kit. So it's very similar to kind of like writing an Express app if you've ever sort of built in the Node stack. Uses Tendermint as well, I think, just as a component.
Binance Chain is using Tendermint. They're using
Binance.
Yes, operation with Cosmos SDK.
Loom.
Loom, yes.
Then there's, if you guys are interested in privacy, the guys over at the Oasis Labs are doing some interesting things with smart contracts, and they're also a REST application built on top of Go Tendermint. So it's kind of the separation of the consensus and networking of the application has enabled a whole ecosystem growth of people not having to worry about the hard stuff and mainly focusing on the UX between devs and users.
If there are no more questions, I think we can take a break.
Yeah, cool.
How long of a break? It's totally up to you guys.
Yeah.
15 minutes?
15 minutes, sure.
15 is a bit tight usually.